Hello, my name is ABISHEK KRISHNA. My registration number is 24MIS0340. Today we are going to reverse engineer a microammeter. So this is the microammeter that we have, and I have taken apart all the components of the microammeter. First, let us understand the components, and then we can go into the working principle of this particular ammeter. Now this is the scale of the ammeter. As we can see, it goes from 0 to 100. It is a microammeter, and therefore it goes from 0 to 100 microamperes. It can measure from 0 to 100 microamperes. So this right here is the casing of the microammeter. It is this that protects all the scale and the pointers inside the microammeters. And now we have the microammeter itself. There are two knobs here. One is a positive and the other is the negative knob. So here is this is where we connect the source which has to be measured, the current that has to be measured. The positive terminal is connected to the red part right here, and the negative terminal is connected to the black part right here. Now we can open this. I have already opened the microammeter, and here as you can see, all these parts are soldered over here, and that is why I have not taken those apart. But we can clearly take a very good look at all the components inside, and therefore that should not be an issue. So here as we can see, there are two knobs. There are two wires coming from each knob. This is the positive knob, and this is the wire coming from the positive knob, and this is the wire coming from the negative knob. And this is connected to the coil right here. The wires are connected to the coil right here. And inside we have a permanent magnet. It is a pretty strong magnet, strong permanent magnet, a cylindrical magnet. And we have a coil right here. It is a movable coil. It is freely movable. I am applying very little force and it is moving very freely. Now there are two springs, one over here and the other over here. These two springs, this is the spring, this is one spring, and this is another spring. Now the pointer was supposed to be here, but it unfortunately broke during the disassembling process. And this is the simple moving coil ammeter. And now let us look at the principle how this ammeter works. Now, when we connect a source to the positive and negative terminal, current flows through these wires into the coil right here. Now, this coil is made up of copper. The copper is wound around the metallic frame. Now, this current passes through the copper, and we also saw that there is a permanent magnet in the middle. And the permanent magnet will have its own magnetic field. Now by Lorentz law, we know that a current carrying conductor placed in a magnetic field will experience a force. Now look closely. The conductor over here, which is the copper wire, is fixed in the middle by the screw right here. And therefore the force that is going to act on this particular conductor is going to turn into a torque, which allows the conductor to turn like this. It makes the conductor turn like this, the coil turn like this. And the pointer over here is connected directly to the coil, and therefore if the coil moves, if the coil turns, the pointer turns along with it. And this is how it shows the reading in this particular scale. The pointer turns and it aligns with one of these values, and that is how we know that this is the value of the current passing through these two knobs. Now there are two springs, as we saw earlier. What is the purpose of the spring? These springs help bring the pointer back from the particular value to 0. Now once it has attained a value, and then we disconnect all these circuits, or if the current stops flowing through the circuit, what happens is this particular pointer has to come back to 0. Only then we can use it again for other purposes. Now to bring this particular needle back to 0, that is why we have these two springs over here, this one and this one. So this is a simple mechanism of a moving coil ammeter. Now there are advantages of these ammeter. The main advantage is that the ammeter is very sensitive. As we saw earlier, the coil moves very freely around with very little resistance, and therefore the ammeter as a whole is very sensitive to current. And the main disadvantage is that if a large amount of current were to pass through this particular coil, it may break this particular circuit, or it may damage any parts of it, and therefore it may not be used again. It cannot be used again. So this is all about my reverse engineering project, and thank you all.